Alright, boys and girls, welcome to our very first lesson on our Chapter 8 subchapter, Radicals. Okay, let's go. Okay, a couple vocabulary words you need to know. There's three important numbers in a radical. The first one, the number inside the radical, that's called the radicand. We have the number in front of the radical. You already know that word. That's called the coefficient. And we have a number, a little tiny written number, written in the upper left-hand part of the radical sign. That's called the index or the root. Okay, so if I have something like 3 square root of 5, 5 would be my radicand. That's the number inside the radical. This 3 right here, that's my coefficient, so I have 3 square roots of 5, and implied here, if nothing's written, implied there is the number 2. That means it's the square root, or the second root. If we don't see a little number written there, then we can assume it is the square root. Okay, just so you know, when we're talking about even, this is okay for even radicals only. So if the root, there the index is an even number, like a square root, the radical itself is always positive. So if I have something like root 9, square root of 9, that's equal to 3. However, if x squared is equal to 9, yes, the square root of 9 is 3 or negative 3, so x equals plus or minus 3. And that's why when we talk about a radical, if we take the square root of 5, for example, the square root of 5 is radical 5, but we need to put the plus or minus in front, because without that plus or minus sign, radical 5 is only the positive square root. Okay, take a minute and write these squares down into your notes. You probably just want to memorize these, or minimally familiarize yourself with them, so when you see a number like 289, you say, oh, I think that's one of those perfect squares. Yes, 17 squared, or 17 times 17, is 289. Likewise, you already know 5 squared, or 5 times 5 is 25. 25 is a perfect square, because 5 times 5 is 25. 121 is a perfect square, because 11 squared is 121. You're writing these numbers down. Stop the tape if you need to, but get these into your notes. Okay, the other thing you need to know about radicals is that any non-perfect square, the radical of that number is an irrational number. An irrational number. And you know that irrational numbers are not rational. A rational number can be written as a fraction. An irrational number cannot be written as a fraction. As you know, a number like pi, it is a decimal that goes on forever. It neither repeats nor does it terminate. So any square root that's not a perfect square is an irrational number. Root 2 is approximately 1.41 something forever and ever. Okay? What's amazing is that root 2, this irrational, very yucky number, times root 2 is equal to 2. So all that yuckiness goes away when you square these irrational numbers. Let's play a quick little game. Rational or irrational? Quickly, you decide. Quick, you decide. Let's start with the first one. Root 25. 25 is a perfect square, so therefore root 25 is equal to 5, so therefore it is rational. Root 31, well, 31 is not a perfect square, so the square root of 31 is a yucky number. A decimal that's not pretty, it's irrational. Root 100, well, 100 is a perfect square. It's 10 squared. Root 100 is 10, so it is rational. And 2 times root 8, well, root 8 is not a perfect square, so root 8 is irrational. A rational number times an irrational number is still going to be irrational. Okay, there are 4 rules of radicals. The first one says root A times root B is equal to root AB. In other words, the product of the radicals is equal to the radical of the product. So root A times root B is root A times B. What we can do with multiplication, we can also do with division. So root A divided by root B is the fraction of, or the radical of the fraction A divided by B. So the quotient of the radicals is equal to the radical of the quotient. The radical of a power is equal to the power of the radical. So if I take a number and raise it to a power and then take the root of that number, that's the same thing as taking the root of the number to begin with and then raising it to the power. The other important thing is we treat radicals just like variables. You can only combine like radicals. In other words, the radicand, the number inside, must be the same, and the root, the index, must also be the same. Radicals in simplest form, there's a couple rules here. All square factors, if we're talking about square roots, are taken out of the radical. In other words, the radicand can contain no perfect squares. All possible radicals are combined. There are no fractions in the radicals, and you can never leave a radical in the denominator of a fraction, because radicals are irrational numbers. We call this rationalizing the denominator. Okay, so as we look at this radical right here, root 24, we are going to simplify this. First of all, we got to ask ourselves, is there any perfect square numbers that make up 24? Well, yes. 24 is equal to 4 times 6. We notice that 4 is a perfect square. So using our rules of radicals, root 4 times 6 can be now written as root 4 times root 6. Well, root 4 is 2. So 2 times root 6. There is our radical in simplest form, 2 root 6. This guy right here, root 180. Are there some nice numbers that go into 180? Sure. Well, we could do 2 times 90, but that does us no good, because neither 2 nor 90 are perfect squares. So, if you need to, whip out your little mini blue calc, but I certainly know that 180 can be written as 4 times 45. And 45 can also now be written as 5 times 9. So this is 4 times 9 times 5. Check my math, but 4 times 9 times 5 is 180. So this now becomes, I'll switch colors, root 4 times root 9 times root 5. Well, hello. Root 4 is 2. Root 9 is 3. Root 5 I can do nothing with. So 2 times 3 is 6, and my final answer is 6 root 5. Root 220. Are there any nice squares that go into that? How about 4? 4 times 55 is root 220. So I'm going to have root 4 times 55. I know I can take the 4 out, so this becomes root 4 times root 55, which is 2 root 55, because 2 is root 4. Hey, this is fun. Root 720. Okay, what goes into 720? Well, I'm just going to break this down in my head here. 8 times 9 times 10 would be 720, because 8 times 9 is 72. I'm now going to break up 8 as to 4 times 2. 9 I'm just going to leave alone. And 10, of course, is 2 times 5. Well, 2 times 2 is 4. So I'm going to think about this radical 720 as radical 4 times 9 times 5. So this becomes, back to Poiple, root 4 times root 4 times root 9 times root 5, which now, go to blue, 2, root 4 is 2, times root 4 is 2, times root 9 is 3, times root 5, nothing I can do with that. Well, 2 times 2 is 4, 4 times 3 is 12, 12 times root 5 is my final answer. If you're really good with numbers, maybe you could have seen right away that 720 is also root 144 times 5. Well, root 144 is 12, so we have 12 times root 5. And it's the same answer as we got down here. Hey, hey. Okay, you guys try these on your own real quick. Stop the tape if you need to, but simplify those radicals. Okay, on the first one, 4 root 24 is also equal to 8 root 31. And I got that by saying, well, 124 is 4 times 31. So I have 4, my original 4 times root 31. Root 4 is 2. So I have 4 times 2, which is 8. 8 root 31. Up here for 80, yes, I could break down 80 as 4 times 5. Or I can see right away that the 80 is also equal to 16 times 5. So what I have here is I have negative 3 times root 16 times 5, which is negative 3 times root 16 times root 5. Well, root 16 is cuatro. It's 4 in Spanish. So I have negative 3 times 4 times 5, which is negative 12 times 5. One more quick little set. You guys go ahead and do these. Stop the tape. I'll come right back to you. Don't miss me when I'm gone. Okay, here we are. Your final answer for the first one should have been negative 9. And your final answer for the second one is 49 root 5. I'll quickly just go through the steps if you want. Well, 1296, I kind of broke down as to 36 times 36. So negative 1/4 times root 36 times root 36. Well, root 36 times root 36 is 36, or you can think of both of these guys as 6 and 6. Well, 6 times 6 is 36. Negative 1/4 times 36 is negative 9. And this guy over here, well, 245 is 49 times 5. So I have 7 times root 49 times root 5, which now root 49 is 7. So 7 times 7 is 49 root 5. Hey, that's it for tonight. We'll see you soon. Bye.